Very good morning. So, this is today's topic, Explainable AI. We will cover a few basics of this topic, Explainable AI. So, have been rejected. Uh, at what places you are rejected, and what was your immediate reaction? If this was the question posed, the common answers will be job interview, rejected. What was the immediate feeling? Frustration, angry, so strong emotions. Similarly, you might have been rejected, say, your online transaction. The immediate reaction will be same, right? Strong emotions will be your immediate reactions. Say you applied for a credit card and you are rejected. The credit card application was rejected. At least my immediate reaction will be this. Say I applied for a loan as I had needed some money. Same thing, if I got rejected, I may have strong reactions, emotions. What would be good to these rejections is an add-on which explains why it was rejected, right? So some explanation, some reason of why it was rejected, so that there is a scope for course correction and reapply. Similarly, let us say you go to a remote or a new city, new place, and suddenly some health issues arise. You go to a doctor, you don't know the doctor, you go to a hospital, you don't know the hospital, and within 2 hours of few tests, or within few hours of few tests, the doctor says you are diagnosed with cancer. So what will be your immediate reaction along with the strong emotions? So you'll not believe, right? First, you'll not believe that you will be diagnosed with cancer. It is highly impossible. Second, you will not believe the tests performed. You will not believe the hospital. You will not believe the doctor. So what will be your natural reaction? You will be again coming back to your place, going to a hospital which you know, going to a doctor whom you believe. So belief, trust is an issue here, is it not? Trust is an issue. Now coming to machine learning models nowadays, what they are doing? The machine learning models are predicting, right? What they are predicting? Say, what will be the sales of next year? Whether the patient has breast cancer or not? Whether the crop disease will occur or not? So these kind of predictions the machine learning model will make. So what is the typical machine learning model? You will be acquiring your data, you'll be pre-processing it, build the model will be doing some prediction, you'll be checking its performance through various matrices like accuracy or precision or others. But same challenge lies here. The machine learning model may be predicting what will be the sales next year, whether the patient is going to get breast cancer or not, the crop will be getting disease or not, say after few days. So for all these predictions, there is a same challenge. What is that challenge? Trust. How do the end user trust? Is it not? So all these machine learning models or online transactions or job interview portals or credit cards, they are using a lot of computing technology, they are using a lot of AI technologies. So but they are missing what is explanation. So that's what this explainable AI is all about. So building the trust through transparency, through explanation, through interpretations, making things easier. So this is actually an algorithm which I usually make people to Google to get connected with the topic explainable AI. So let us click on this link of the website Data Camp, which has a very good how do I put it explanation of this topic explainable AI. So here it is highlighting the word trust, then it is saying these are the principles for trust: transparency, fairness, trust, robustness, privacy, interpretability. So this is what is an explainable AI. So you'll be bringing explainable AI through these aspects: transparency, fairness, trust, robustness, privacy, interpretability. So here this datacamp.com is explaining that there are two categories of explainability: model specific and model agnostic. So here there is some sample code which is used to build a classifier, and this code is to predict diabetes outcomes. The data set being used is diabetes data set. So that's it. You are having your code, you are bringing libraries, you will be creating your data sets into test and train data sets, then you will be using performance metrics and so on. So these are the performance metrics: precision, recall, F1 score, support, accuracy. So now this is what happened here. What has happened here? That's what I had said, that the machine learning model is predicting, in that case, diabetes. What it is predicting? Diabetes. Okay. What is missing there? The missing component is the explainability part. So you need to add an explainability layer in this model to provide insight into its prediction. So as mentioned in this datacom.com website, there are two explanative model methods, you can say: model specific, model agnostic. So model agnostic method, in that it is mentioning SHAP, and I had requested I usually request my students to Google for this so that they can get. SHAP actually is explainable AI. SHAP actually is shapely additive explanation. This is a method to explain the prediction of an instance by computing the contribution of each feature to the prediction. So how do I install SHAP? By using this command. So after the installation, you will be importing the SHAP library. There is a tree explainer class which is used to explain tree based models. There is something called a shape.initJS function which initializes the JavaScript code required to display SHAP visualizations in a Jupyter notebook environment. After instantiating the tree explainer class with random forest classifier, the SHAP values are computed for each feature of each instance in the test dataset. So this is what you imported SHAP, you imported library for plot, then initializing JS for visualization. There is a tree explainer, okay, and then now you're plotting the SHAP summary plot. So as you can see here, you are having the SHAP values here, and you can see there are two colors, and these are various parameters for diabetes: glucose, age, BMI, diabetes pedigree function, pregnancies, skin thickness, insulin, blood pressure. So you are having two colors here, so indicating two classes, one color blue, the other color red. Okay. uh, if the class label is 1, that indicates diabetic. If the class label is 0, that indicates non-diabetic. And you can see that glucose, age and BMI, the first three, they have the higher predictive power. The others like skin thickness or insulin or blood pressure are having lower powers. You also have summary plots wherein the features are ranked by their average absolute SHAP values. X-axis is the SHAP values. Positive values will be given for a feature which pushes the model's prediction closer to the label being examined. Negative values will be pushing towards label 0. Suppose you have red dots and high glucose level, they'll be having positive outcome. So this kind of explanations and along with dependency plots will be used. So what we concluded from this Googling request for Googling SHAP is a method for explanation. So immediately we also have something called as LIME. So LIME also again is a method for explanation only. So LIME stands for local interpretable model agnostic explanations. LIME focuses on individual instances. How do I set the LIME explainer? You have to import the LIME module, fit the explainer using the training data and the targets. So mode is the classification mode. So you can see here, we are importing here the LIME tabular explainer module from this library, lime.lime_tabular. So these are the two classes, has diabetes, no diabetes. The feature names we are listing out from the columns of the training data set. Then here you are setting the line tabular expression, so fitting rather. And you can see here this lime is has shown 8th instance in the test data, and it used random forest classifier, and it provided the feature contribution in a tabular format. So it has predictions, feature contributions. So say these are the features, and actual values of each of the feature. You can see here 72% confidence level is there. The glucose level is 99% or more. Blood pressure is 70 or more. So you also have a model. These were the Sharp and Lime were model agnostic, while you also have model specific method also, like linear regression, decision trees, neural network interpretive, deep lift, grad cam, integrated guidance. These are the model specific method. So let us go back to my cheat sheet. Uh, there is a lot of privacy, safeguarding the data related movement going on, and we know in Europe GDPR is already there. So and what is GDPR? So that is for safeguarding the privacy of data. Let us Google for GDPR, and this is General Data Protection Regulation, European Union regulation for information privacy. So it is set in motion in India too. So all these aspects again are interrelated, wherein you need to have privacy, you need to safeguard yourself, your data, you need to have explanation component, you not want to make a better society. That's why society 5.0 also comes into picture. So what is society 5.0? All the technology integration to be applied in the real world, and making things smoother and easier for the society. So when I am speaking about GDPR, when I am speaking about predictions, when I am speaking about explainable AI, I also divert, I can say, on EHR. What they say about EHR, they are more valuable than money and diamonds. And what are EHR? Electronic health records, right? So they are also put on cloud. There also is a challenge of privacy, safeguarding the data, and so on. So let us have a quick walkthrough of the presentation slides for explainable AI. Explainable AI usually is in the literature is mentioned using this fancy short form XAI. Actually, it is what is explainable AI is AI which explains decision making. How explanation is provided? Using machine learning, which are having the capability of explanation such as decision trees, knowledge graphs, similarity models, or come out with new models using complicated neural network. Previously, AI was a black box AI, like it did some predictions, it did some decisions, it did some recommendations, and it did not tell why. So there was always at the end user there was a confusion why the decision was made, why other decision was not made, did it succeed, did it fail. But with this black box AI, the journey is evolving to something called as glass box AI or white box AI, wherein an explanation component is being added, right? So this explanation component will give the answers to the end user, such as why have this recommendation was given, why this decision was made, why another decision was not made, whether it was successful or not, is there a scope for correction in the error, and kind of thing. So this is what is our journey from black box AI to white box AI. So black box AI could not answer the questions why, when, how, while the white box AI or the glass box AI will be answering the questions why, how, and when. Here are a few examples being made. Like for example, Watson. We know what is Watson, right? Watson is IBM product, and there was a talk once that it will be replacing lawyers, it will be replacing doctors, because what exactly Watson will be doing is it will be, say, if you want to have some help in legal aspects, it will give you medical aspects, it will give you. But what exactly or how exactly Watson operates is it is a data corpus, right? It has a huge data corpus. As you go on adding the data corpus, it will be fine tuning in, and it is kind of answering your questions, question answering mechanism, say on the lines of chat GPT. So whenever we are having without explanation AI, it's a black box, uh, and these kind of questions may arise in to the various stakeholders. Say there is a business owner, he may say, can I trust? There is a customer support, he may feel, how do I answer this customer complaint? If there is IT operations guy, how do I monitor and debug this model? If there is a data scientist, is this the best model that I can be built? If there are regulators, are these AI systems decisions fair? All these questions will be creating confusions, doubts will be creating whenever you have black box AI. So these will be resolved by white box AI. Uh, to the black box model of AI, you will be putting an explainable component which interprets, and that will be augmenting your AI. So when I'm speaking about explainable AI, I'm speaking about responsible AI, understandable AI, traceable AI, and it becomes a responsible AI. Say for example, you are using a machine learning model to identify this is a cat or not, and you are getting a accuracy of say 93%. Is it not? You have this training data, learning process, there is a learning function, and you are saying that this is a cat with this. So, but user may not get these answers of why, when, and how. But in future, with the new learning process and the new explainable model, you can say that this is a cat because it has features like fur, whiskers, claws, and user may get the answers of why, when, and how. So this is in a nutshell, a brief introduction to explainable AI. You also say, for example, this slide says Facebook is adding explainable AI to build trust. So it usually says why I am showing you this ad kind of thing. So here we are mentioning that lime and sharp, and here we are mentioning what we are adding to the machine learning model, the interpretability aspects, human inspection aspects. So here we are mentioning the two methods, model specific, model agnostic, and we had seen the model agnostic ones were sharp and line, where the model specific were like decision trees and so on. You can see here agnostic approaches are lime and sharp. Okay, so I'd like to stop here, and these are few of the papers I referred, uh, such as fair prediction with disparate impact, Amazon scraps secret AI recruiting, then identifying challenges for humanity organ. These are few of the papers. Thank you.